So in this question, the first part was basically we had to figure out what transformation maps 1 upon x onto this function. So let's say 1 upon x onto this function. I had already given the explanation. So here the question is, let's say first you're going to write down 3x minus 7 upon x minus 5. Basically long divide this. You're going to get 3x minus 15. So this is going to be minus, and you're going to get this as plus. This is 8 out here. So you can write down 3x minus 7 upon x minus 5 basically as 3 plus 8 upon x minus 5. So quotient plus remainder over divided. So that's the first part. So basically, you can clearly see now that this is 1 upon x. So this is, you can clearly say, okay, this is a vertical stretch factor by 8. So you get 8 upon x function. And then you translate by vector 5 and positive 3. So 5 and positive 3. So this can be very helpful to sketch the graph directly. So if I look at the simple 1 upon x graph, 1 upon x graph is here, which is this 1 upon x graph. Now, if I do vertical stretch factor by 8, the shape is going to be more or less the same. It's just vertical stretch factor by 8. So if I assume that this is 8 by x graph itself, I mean 1 by x graph would be something like this. If I do the vertical stretch factor, it will become something here. Now, if I move the graph 5 units to the right, so my new function, if you see here, if I move 5 units to the right, so the new vertical asymptote is x equals to 5 here and y equals to, let's say you get y equals to 3. So 5 to the right and 3 units up. So you're going to get this branch basically, which is here, shifts out here. And then to get the accurately the y intercept and all, you can just plug x as 0 to get 7 by 5. So here will be 7 by 5. This part you'll have 7 by 3. So you can see approximately the graph of this is out here. And you need to have the proper definite point out here, After this part, we have to sketch the graph, or solve the absolute value of f of x greater than 4. Now, obviously, we got to sketch the absolute value of f of x. So when I'm sketching the absolute value of f of x, only this part which you see gets reflected in x-axis, and this part remains as it is. So this is the original graph, of course, including this one. Now I have to see where is it greater than 4. So now you just draw y equals to 4 line. Since y equals to 3 line is here already, it's fair judgment to draw y equals to 4. Now if I can just show to you for where is my inequality holding true. So it is holding true here and in this range. So these two intersections, so the first intersection is this one and second intersection is this one, you got to find out. So when I'm finding out the first intersection, see, this is the original function. This is the original graph itself, because this branch I did not reflect in x-axis. The equation for this branch is 3x minus 7 upon x minus 5. But this branch is actually the reflection in x-axis. So equation for this will become negative of 3x minus 7 upon x minus 5. Because you're reflected in x-axis, so that's why the equation for this particular branch is negative f of x. Now, our next part is to actually solve for intersection. I'll just clear out this part. So we have to solve for the intersection of these two points. Now, here, this one I'm going to equate. So minus 3x plus 7 over x minus 5. Remember, don't multiply this with denominator also. That's a common mistake we do. Equate to 4. So you'll get minus 3x plus 7 equals to 4x minus 20. Bring it one side, so you'll get 7x equals to 27. So x is 27 upon 7. So this coordinate is basically 27 upon 7. And now to get this equation, this intersection, you're going to equate 3x minus 7 upon x minus 5 equals to 4. So you'll get 3x minus 7 equals to 4x minus 20. So you're going to get x equals to 13. Because this side, if you get here, will become positive 13. And this one will become x. So you get x as 13. So this intersection that we got is 13. Now, when you're writing the correct solution for this, actually will be that this is greater than 4 for, the final answer for this inequality is, you can see that it is from 27 by 7 until this point 5, 27 by 7 to 5. So x is basically belongs to 27 by 7 until 5. Both are open brackets because it's not included here. And because of vertical asymptote, you're not including this 5. Union with 5 to 13. So this becomes the correct range where absolute value of your function is above 4. So this is how you kind of use the graph part. This is what is expected. Here we did not draw sign diagram. We did not do any kind of trial and error. So that's why graphical approach is always good for rational inequality solving. If you could draw the graph and you could plot it properly, then you can do it. Our next part is to draw f of absolute value, solve f of absolute value of x is less than 1. Now what I'm going to do is, I'm going to first clear out this part, which is drawing of the absolute value of f of x. So this was my original function. Now I'm going to draw f of absolute value of x. So when you're drawing f of absolute value of x, remember that you always cut down the left side of the graph. So your left side of the graph is going to be erased. So this part, which we have here, gets cut down and reflect the remaining part across y-axis. So this part, this is going to become minus 7 by 3 here. And this part is going to be actually out here. Then we have here as this part. This will become completely symmetrical. That's f of mod x graph. Now our next challenge is to solve where is it below 1. Where is this function below 1? So 7 by 5 is obviously higher than 1. So you've got to draw y equals to 1 line here. If I draw y equals to 1 line, this is where it is. And if I can show, now correct range of x values that I'm looking forward, that is this range and this range. Graphically, you can visualize it properly. Graphically, you can understand for what x value is your function below 1. So this is where it is highly recommended to use the graph in such case. Now, what you're going to do is, after this, we are going to find this intersection. Since this is the original curve, you can either take the reflection y-axis or this function to get the intersection. So I'm going to take original curve, 3x minus 7 upon x minus 5 equate to 1. So 3x minus 7 equals to x minus 5. So you're going to get 2x as 12. Sorry, 2x equals to plus 7 minus 5, which is basically going to be 2. You're going to get x as 1. So this coordinate is basically x equals to 1. So automatically this becomes x equals to minus 1 because f of mod x is a even function. So it's symmetric about the y-axis. So this now correct range in this case will be x belongs to, for the solution for the second inequality is here, x belongs to minus 5 until here it is basically minus 1 union with 1 until 5. So that's the correct solution range that we are looking forward to this part. So when you are sketching f of mod x minus 1 graph, it is of utmost importance to understand in what order you're doing the transformation. So here, the first thing is that we're going to take f of x graph. We're going to basically move 1 unit to the right. So the graph which we had here, roughly, this was the graph, which was x equals to 5 was the vertical asymptote. Now x equals to 6 is going to become the vertical asymptote. Horizontal asymptote remains at the same point. Okay, so this is here the graph will be. Now the axis intercepts are going to become different, so that we are not finding out. Now we're going to do f of mod x for this. So since we got this, just to replace x with mod x, we're going to do f of mod x minus 1. So f of absolute value, this part gets cut, reflect the remaining part in y-axis. Here you're going to get x as -6. This part is going to remain the same. So this is approximate tentative graph of f of mod x minus 1. Now, to sketch this part, you first move the graph one to the right. So if I move one to the right, you got this part, which is here. I'm just going to erase this one. So this is the graph of, so in this case, you're going to first draw f of mod x, you can see. So in this second case, your graph is going to become x equals to 5, and you're going to draw f of mod x here itself. So cut down this side, y equals to 3 was the horizontal asymptote. So this side will be f x equals to -5. Here you'll have this reflection. Now you move the graph one to the right. So if I move one to the right, now you can see here, you'll have the new, this thing asymptote. This vertex, or you can say maximum point, will shift here. You can see graph itself is now becoming completely different. Here you'll have the new asymptote at x equals to -4 now. So x equals to -4, and then this side obviously comes here. So the correct graph for this side will be logically this part. After that, it will be this part. This will be the new asymptote here at x equals to 6 and x equals to -4, and here will be the next graph. So just remember that these are some of the very interesting applications of the absolute value.